Hey guys, welcome back. Today in this video we're going to be talking about pendulums. We're in the middle of a chapter that's talking about vibrations and moving into waves. We talked about spring mass system, now we're talking about pendulums, and pendulums also undergo simple harmonic motion as long as we keep the swinging angle to smaller end, sort of less than 15 degrees kind of thing. So a pendulum is defined as a light massless string or wire that has a length L. It has a bob at the bottom. The bob has a mass. We assume it to be a point mass, meaning it's not really tall where we're not sure where the center of mass is. It's sort of right at that length. Now if we just have that there looking at forces involved, what we're going to have is mg down due to the bob, and we're going to have force of tension of the string. Okay, so when we have that object swing up here through an arc, we're still going to have mg because gravity hasn't changed, but the restoring force now is going to be at some angle to the vertical. Okay, so if we're looking at forces, say when this thing gets up to 30 degrees, we would just have to use the sine or cosine of that 30 to some forces in the y direction equal to 0, and we could find out what the tension would be in that right there. So what equations do we have that work with these pendulums? Well, we have obviously the forces there. We have the period is 2 pi square root of the length over gravity, and since frequency is 1 over period, it's going to be 1 over 2 pi square root of g over L. So looking at those equations, if we increase the length, the period should go up, meaning it should take longer to get through one complete swing back and back over. If gravity would increase, that would make the period go less because it would be pulling, restoring force of this gravity here would be pulling it back sooner, less period. And if the length got longer here on the frequency, we'd see the period goes up, which means the frequency goes down. Okay? And going back to this, just so we talk more about that restoring force, if we did a parallelogram method, we would find that the restoring force, Fr, is what's pulling it back to center, but it's going to swing past it. And if we could get rid of air resistance and other frictional forces, that would continue forever, but it doesn't. Alright, so if we're going to do a quick problem here, let's just throw out some numbers. Let's have a length of 1 meter, and obviously I could tell you what the mass is, but it doesn't matter. How do we know it doesn't matter? If we look down at our equations, there's no mass in any of these. It doesn't affect the period. As long as that mass is not some huge building that we're swinging from a 1 meter rope, and we ignore air resistance, it shouldn't matter. So I'm just going to sort of cross that out. What else can we put in here? Obviously, if we don't say what gravity is, we assume it's on Earth. And we could just find out what the period is and the frequency for that 1 meter long pendulum. Okay? So, it's as simple as taking these equations and plugging in. That's 2 pi. It's going to be 1 meter on the top. Gravity is 9.8. We go through that. We'll come up with so many seconds. We take 1 over t. We get the frequency, and that's going to be in so many hertz. And again, I'm avoiding doing the calculations because you can do that yourself and easily in there. Okay, just be careful when you use this pi, especially when you're dividing it, like down here. If you do 1 divided by 2 divided by pi, it may work on your calculator. You just want to double check. That should be really 1 divided by like 6.28. So make sure you get that correct there. So that's as simple as this for pendulums. Now if we were looking for, because I know this question came up, if we want to know the force and tension as this was swinging through a certain amount, we might have to look at our radial or centripetal acceleration and the force, centripetal force involved with that. But we're just talking about if it swings up here and comes to a stop, what's the force of tension.